Hello everyone, welcome to my demo where we'll be doing token creation or coin creation on the Ethereum blockchain. And before we begin, some of you might ask, okay, why do we need yet another coin? But people have their reasons for coin creation, token creation, maybe for crowd sale, fundraising, charity, even in the classroom, educational, university, exploring the blockchain, see how transactions work, mining, that sort of stuff. So there are tons of reasons for creating tokens or coins. Just recently, someone tokenized their time. So we have tokenization of someone's skills, someone's time, tokenization of companies, organizations, tokenization of shares even. Okay, so that being said, this demo is for people who may not know how the token creation is done, and so this gives an idea. Also, those who understand like programming and solidity and the Ethereum blockchain can use this demo to to create a token. That's because a lot of resources we have out there on the issue of token creation, they're very old, 2015, 16, and they don't apply to today, or they don't even work today, right? And today I'm speaking about June 2018. Okay, so we can use this now to create tokens or to tokenize something. Okay, so what we'll be using, as we can on the screen here, we see Remix, I believe formerly known as Browser Solidity. So here we can, well, it's a compiler on the Ethereum virtual machine, so it's not connected to the Ethereum blockchain or to the testnet. Right, so here we can experiment with code. Right, so we'll be using Remix. Okay, and when we open Remix, you go to remix.ethereum.org, and it takes you to this page. You're given like a example demo contract, right? So to get started, you can just copy the first line, pragma solidity 0.4.4.23 or 2.4 or 2.5. This is just the it's just the version number. Okay, and what you want to do also is remove remove the S, make it HTTP instead of HTTPS, and it should work fine. Okay, so this is what Solidity, this is what the compiler looks like, and we just do like a demo. So we have like contract, we call this contract data. We just do something just so we can see how it works. Okay, so we'll enter something, and if this was live, it would like enter value onto the blockchain, and then someone from outside can request this this data after it has been entered and saved and mined. Okay, so we'll have a function for, let's call this one enter. All right, and we'll enter, this is the data type, so we enter a number. All right, and we'll call this x. We make this public. what else do we have here? So we enter here, and so we have the date. Oh, we have data equal to data is equal to x. Okay, so we need to do one more. Well, do something here, which is to declare this variable. Alright, so this piece here, function enter. This is where we would enter the information, and we have a function a read. We can call it read. Alright, so read something. Make this public, and also we will be able to view it. And this should return. We wanted to return a number, just like we entered. Okay, and we will return return the data. Let's see if this works. Alright, so we compile this one. Whoa. Ooh, constant. This should be contract. Okay, let's try again. Compile. Okay, good. So this is it's a yellow warning. This means it will still compile. Okay, that's no issue. Let's go to run. Let's deploy this. Alright, so here we have enter and we have read. So enter would actually like write to the blockchain, and our integer, inside integer, meaning like plus, not minus. So let's say 8,000. No, let's say 50,000. So we enter this. Right, and once this is deployed and assigned, anyone can come and read this afterwards. So we have read, so our integer is 50,000, and this is a simple contract. I think it's the simplest contract you can write. Someone might say, okay, well, you can write a simpler contract by just like doing this, but this does nothing. So what we had here, it actually does something. Okay, this is just Solidity, and we should be familiar with this before actually like trying to like make coins or like work on the testnet or work on the actual blockchain. Next we have, so we'll use Solidity, and next we have MetaMask. Okay, MetaMask, will use MetaMask for, okay, what MetaMask does, as they said, brings Ethereum to your browser. So we have the blockchain which we want to write to, which we want to interact with, but we are doing that interaction from a browser. So therefore we need MetaMask, okay, so that our browser can speak to the blockchain. Okay, so here we don't really need MetaMask here, but for deploying a contract on the blockchain we need it. Okay, so they said that we can get it on Chrome, Firefox, Opera, or get the Brave browser, and that's what I did. Okay, I installed the Brave browser. Okay, good. So let's move over to the Brave browser where things get a bit more serious. So let's go over here. Okay, let's go over here. So we have Solidity here also. Okay, however, this Solidity, unlike the last one, which was this one here, if you notice, this one is running JavaScript virtual machine, the Ethereum virtual machine. This Solidity, because it's connected to MetaMask, see MetaMask here, this one is connected, while this one is not. We don't have MetaMask on the Safari. It's not even allowed on Safari, so we have it over on Brave. Okay, so this one is gonna run, it's gonna, MetaMask is connecting Solidity to the blockchain using Web3 injection. Okay, this is how it's getting this done. So we have MetaMask connected. Let's see. Yes, we have MetaMask connected here. Right, we have two accounts. Right, I'll just name the account Solidity 1, Solidity 2. Okay, let's see what else. Good. So Solidity is connected to MetaMask. Everything happens like you have to do anything. Just once you log into MetaMask, Solidity will connect automatically, or it will connect to Solidity. Right. Here, if we have HTTPS, it's no problem. It still works, unlike when it's running on the virtual machine. Okay. Now after this, here we need code. Okay, we need our code. So what we will use for code is Open Zeppelin. Okay, it's for Solidity contract. So we search for Open Zeppelin and go to the GitHub, and we have loads of contracts here. Now, why we use these contracts? We can use contracts from Open Zeppelin, or we can use contracts from the Ethereum website. They give like a code, where you can copy and tweak it to your purpose. And here we have tons of code here, which we can tweak to our purpose, whatever we want to do with it. Right, it still takes some work, but these contracts on Open Zeppelin, they have been tested, and they have been improved over time by a lot of contributors. So we can take one like as an example and modify it to suit. Okay, and that's what I did. So I wouldn't like do the whole modification. I'm just saying that get your um, get your Solidity up, get your MetaMask connected, go over to Open Zeppelin and get some code, and modify your code for your token, or for your coin. Okay, or go to the Ethereum website and get some code from over there. Okay, it's, as I said, it still needs to be modified to suit you and your purpose. Good. Next thing I want to add is that in if you're just gonna okay, you may come across some errors, and the errors I came across were, for example, let's go to token. Let's go to ERC20 token, and your token. Well, if you're gonna do a crowd sale, especially, your token must be ERC20, because it has to be like that to interact with other wallets and to interact with the exchange and the like. Okay, now let's say you go to Open Zeppelin, you want to like do a ERC20 token, and you copy this code ERC20. Now here's what error here's where you're gonna get you may get your error. You see here, contract ERC20, this contract here is ERC20 basic. If you try to run this code by itself, you'll have an error, because ERC20 is a sub contract. Right, so we have some inheritance going on here, just like inheritance we have in Java, for example. In Java, we would say ERC20 extends ERC20 basic. Here, the inheritance is done using the word, what the verb is. Okay, so this means that for us to run this sub class or subcontract, we must get the super class, or the parent contract. Okay, so we can't run ERC20 without having the code for ERC20 basic. Okay, I hope that's clear. You see, ERC20 basic. So we must get this code first, then get the ERC20 code. That's number one. Number two is check if you have any errors other than that. Then check your variables. Okay, we have variables, for example, like value. Okay, we have variables such as spender, value, owner. These variables. What you need to do is check, make sure if it doesn't work, make sure, and this is ERC20, check ERC20 basic and make sure that the same values are being used. Sometimes it's spelled different and this will later error. Okay, sometimes we have like an underscore before value, and yeah, that won't work. Okay, so these are the two errors I encountered. Okay, let's go back over to Brave. So let's have something called okay, so yeah, so we have this is one contract. The simple token is standard token. This means that standard token is this means that simple token is a subcontract and standard token is a parent. Okay, so we have a few contracts going up. Okay, so this contract is of a simple token. All right, so let's get our public name. Let's get the name of our token, and I will call this UFC coin. Okay, fan of UFC, Team Khabib. And the symbol will be UFC. Okay, decimals. I just want 2 decimal places, and the initial supply is 1 million. Now if I put 1, let me see, 1 2 3 4 5 6. Okay, so if I put this like this, 1 million, it's going to move the point and take out 2 zeros, so the point is going to land here. I don't want this, I want a full million, so I need to add 2 more zeros to cater for that. Okay, and that is about it. And let me try to compile this. Okay, yes, it compiled. Let me try to run. Simple token, deploy, deploy. So MetaMask, good. So this is running on the blockchain, not the Ethereum blockchain, but the testnet. Okay, and the reason why it's we're doing this on the testnet, because if it runs on the testnet and everything works correctly on the testnet, then it should work on the mainnet. Okay, so we need to approve. MetaMask is going to ask for some approval, and we're going to approve this, of course, with our key. Okay, MetaMask handles everything behind the scenes. No need to copy and paste private keys, so we already logged in, so submit. Okay, so it's contract deployment. UFC coin, symbol UFC, 1 million coins. Okay, it was deployed. Yes, it was. And let's check the blockchain to see what's happening. So this should take a few seconds, but as we can see, our contract has been deployed, so it's a success, and it's from me. Okay, 252858, right? I'm the creator of it. Okay, C7BC B7, yeah. So now it's for me, right? And this is the contract address. Okay, contract was created. So let's check my balance to see how much I have. So the copy address to clipboard. Let's check. Okay, so here we can actually interact um, with the contract, right, from here. So the address of the owner. Okay, we paste my address. Let's put quotations, and check my balance. My balance is one million. It's 1 million tokens. Okay, as we have two more zeros there, but the two decimal places will take care of that. Let's now, okay, let's go to my address. Okay, and contract creation, token transfers. Okay, let's try to send some coins to another address. So let's switch to Solidity 1 and copy address, switch back to the contract address, and let's try to transfer to our second address 500,000 tokens, UFC tokens. So we're transferring half of our tokens to another address, transfer. Okay, MetaMask asks for some approval, and we authorize this, and let's see. Let's go to the scan, ether scan. Where is this tab? Okay. So we actually created we created 1 million tokens, but only 5,000 of them were transferred, and that is because the contract applied the two decimal places. Okay, the contract applied the two decimal places. Yeah, so this is why we do stuff on the testnet, so we can like sort out these issues. So here our coin is stable, our coin is running. So to complete this order, we will just need to transfer the rest of coins to the second address. So yeah, it wasn't perfect, but I hope we understood, or we got an idea as to how contract creation works, how tokens work, and I hope that someone can benefit from this and get on with some tokenizing. Okay, so that's all for now. Bye.